Hi there. This is Jacob Nash Review, and we're going to be reviewing Module 6. I call this Correlational and Experimental Data. All right. Well, remember, we talked about descriptive data or research in Module 5. Now we're going to talk about the other two kinds. All right, well, let's start out with correlational. So what is a correlation? It is the extent to which two variables change each other. So it's sort of like a relationship between them. And the correlation coefficient is a measurement of the relationship between two variables. So basically, the coefficient is just a measurement of correlation. And it ranges from -1 to 1. Now, you have to notice that -1 is not weak. -1 is actually super strong. So is 1. So if you see this sort of number line, if we go backwards down the number line, you see that all the way at the back is MacGyver, who's strong. Look, he's holding that like missile or whatever that is. But when it's at 0, that's weak. And what does this mean? Strong means we can absolutely, for sure, say that they're related. Now, you're going to see something soon that is not what you want to say, but I'll get to that in a second. So that's if it's closer to 1 or -1. But if it's 0, it's like, it doesn't seem like there's any relationship between them. That's just random. I mean, so that's what the coefficient means. So we can use scatterplots to display this. So can you guess from these 5 graphs which one is strong positive, weak positive, strong negative, weak negative, and none? If you want to guess, you can pause. If you don't, then just see what I show you. So let's start with this one. That would be a strong positive. Notice that all the dots go up as there's nothing labeled on the axes, but as whatever this is, the X would be whatever thing is going on to see if it has an effect on what the Y is. So since the dots are close together, that would mean that it's a strong correlation, and since they're going up, that means it's positive. This one is a weak negative because if you notice, they're going down, but they're not that close to each other. You have a lot of outliers. Then this one, that's a strong negative. See, they're close together and they're going down. And then this is a weak positive. They're going up, but they're not close to each other. And then that one's just none. Look, they're all over the place. It doesn't look like it's going up or down. So something really important. Let's say on a free response question, you said, scatterplots and correlational data show cause and effect. That's what Wundt would do. He would be really mad. So pay attention. Scatterplots do not show cause and effect. They do not. Instead, you have to have an actual experiment. But we're going to get to that in a second. Experimental. All right, illusory correlation. This is just a relationship that doesn't actually exist. So it's like you think something, but then you're like, well, that's not even true. It just seems like it, but it's just a kind of a coincidence or random. So let's say that Anthony Kiedis was trying to test if wearing no t-shirt for a long time increases the concert money that he gets. Well, let's say that he takes a graph and that's what it looks like. And he's like, I knew it. But then John Frusciante is like, no, that's illusory correlation. Yeah, there's just 3 dots and they happen to sort of look like they're going up. That's not a correlation. That's just random. Sorry. All right, then there's longitudinal research. This is just studying the same individual over time, simply. So a good example is to think of identical twins. Maybe they're studied throughout many years, and they're going to see some similarities or differences. And that's a type of correlational research. Well, now let's talk about what is cause and effect, and that is if you do an experiment. This is a research method that manipulates multiple factors to observe the effect on some behavior or mental process. And there's usually two groups that are studied or observed, and that's the experimental group and the control group. So if you see these vunts here, there are 6 that have pills in their mouth. There are 6 that don't. The 6 that do are the experimental group. They're exposed to the treatment, which that doesn't always mean like an actual treatment. Like it could be whatever you're trying to do to see if it has an effect. The control group is just what you observe that's just normal. If you only had the experiment group, you wouldn't know what to compare it to. So that's why you have the control group, just to see, all right, here's the normal vunts. Let's see what it's like for them. All right, well, the ones that have the pills, let's see how it's different for them. Random assignment. This is a good thing to do. This is assigning participants to experimental control groups by chance. So basically, you don't know which vunts will have the pills and which won't. You don't know. And why is this good? Well, we're going to talk about something else that's similar, which is the double-blind procedure. This is when even the researchers don't know which group got the treatment. In this case, maybe only the participants don't know. But if both the researchers and the participants don't know, that makes it more accurate, because basically you won't have some sort of bias or something will be changed slightly. If someone knows they're getting a treatment, maybe they're going to act differently because they think that it has an effect on them, and that affects the data and makes it inaccurate. Or if the researcher knew that, it might change something that they do. But in any case, one of the groups in a blind procedure, double-blind procedure, would have a placebo. This is basically a fake thing that is like the actual independent variable, but it does nothing. So that way that it's the same for both. So these vunts, they have yellow pills or green, whatever color that is, and they think that it's real. But the only reason why, the only point in making them think that it's real is so that there's no sort of bias, because if that's the point, to see if there actually is a change, which is not just something that is something that they have falsely developed, sort of. So that's what a placebo is. All right, there's 3 kinds of variables that you need to know. There is a independent variable, dependent, and confounding. Maybe you've heard of the first 2, maybe all, but let's see what they are. The independent variable is the thing that's changed to determine an effect. So, for example, the independent variable here is giving them a pill. That's the thing that's different. It's changed. The dependent variable is the result. So really, independent is the cause, dependent is the result or effect. And then there's something called a confounding variable. These are bad, actually, because there's something that it changes, but it's not supposed to, or maybe the researcher didn't think about it. So let's say that Anthony Kiedis is sent in as an independent variable to see if that has an effect on the audience. So you see the audience is clapping. So you might be able to think that, oh, because of Anthony Kiedis, the audience is clapping. But you might not think about the confounding variable of John Frusciante. That might also affect why they're clapping. Maybe they like what he's playing on the guitar. So that is something that researchers might not have thought of. That's another thing that could change what happens here. All right, the validity. This is just the degree to which an experiment reports what it was intended or was supposed to. So that kind of is straightforward. All right, let's compare the 3. So remember, we talked about descriptive on Module 5. Let's talk about all of them now. So this is just kind of a review. Descriptive, the purpose is to observe a behavior or record it. Correlational purpose is to detect natural relationships. Experimental is to explore cause and effect. So remember, you don't want to make Vunt mad. Correlational, no, that's not cause and effect. All right, well, how do you do these things? Well, for descriptive, you can do a case study, remember? Naturalistic observation, basically like spying, remember? And then surveys. Correlational, you just detect that by collecting 2 or more variables. But that's all you're doing. You're not changing anything. You're just observing it. Now, for experimental, you're manipulating, which means you are changing something. You're doing something to see what happens. So what's changed? Nothing has changed for descriptive. Nothing has changed for correlational. You're just observing natural things. But experimental, you're changing the independent variable. The strengths and weaknesses. Okay, the strength of a descriptive is that one person. Oh, yeah, sorry. It's one person if it's a case study, and it's quick to get. Now, this one, the correlational, works with large groups. The cause and effect is clear for the experimental. That's why it's useful. And then the weakness is uncontrolled variables may be inaccurate. Cause and effect can be unclear. And it's not always applicable for an experiment. You can't just always do an experiment when you're trying to find something out. All right, let's look at some questions here. As always, you can pause it or you can just watch. But which variable is the outcome that is measured by the experimenter? Once again, I didn't make these questions, so sorry if that's not correct. Well, the outcome is always a dependent variable. What type of research method restudies and retests the same people over a long period of time? Remember, that's longitudinal. Oh, wonderful. It didn't show up. Which research method seeks to establish cause and effect relationships? That is experimental, not correlational. When would a researcher use the double-blind procedure? Oh, now it shows that one. Okay. A researcher should use it if they want to make sure that the participants will not know which group had the placebo and which is the real treatment. An example could include drug evaluations. Which research technique could measure the relationship of 2 variables? That, in fact, is a correlation. Or they could use a correlational coefficient. And they could also use a scatterplot. Well, either one, but create an example of an experiment. All right, here's an example. To investigate the effects of soft drink on behavior, Early gives one group the question drink and the other a similar tasting placebo drink, so the participants don't know which drink they received. Early is also unsure which group is which. He made sure to assign the participants randomly. The independent variable in his experiment is the type of drink given, and the dependent variable is the change in behavior on the non-placebo group. How can a researcher generalize their findings? Do you remember what that is? That's something that means that it can be used by any other scientist. Well, that is, they can be generalized if any sampling bias or limitation is eliminated, so the samples are as random and therefore accurate as possible using random assignment. That's what they can do. Oh, there's kind of a lot of questions for this one. Sorry, but I guess it's better to know more than not, but whatever. Which variable is manipulated? That is the independent. Create an example of a strong negative correlation. As shoulder width increases, extreme behavior decreases in nearly all cases. So remember, a negative one's always going to be, as one thing increases, the other decreases. or technically as one decreases, the other increases, but usually you don't say it like that. It always, I mean, typically the first, you're talking about the x-axis increasing. That's usually how you read a graph. But anyways, create a strong example of a strong positive correlation. As shoulder width increases, extreme behavior increases. They do the same thing when it's positive. If the experimental factor, the experimental factor that's manipulated is the independent variable, not sure why there was a repeat question, sorry. What is used to reduce the effects of compounding variables? Remember, that was like John Frusciante, like changing what the audience thinks. Random assignment. So I don't know if I might have not mentioned that, so sorry about that. But random assignment, remember, random, whichever control group or experimental group is random, that can help reduce compounding variables. Sorry, I just knocked my mic down. Create an example of a strong correlation using a correlational coefficient. So remember, it's got to be close to -1 or +1. So 0.96, that's a good one. Okay. Create a moderate positive correlation scatter plot. So that means it's going to be like kind of going up, but not super close together line or dots. As age increases, reflective thought process increase. All right, and here's the last seven, I mean. Create an example of an independent variable. Early manipulates the number of hours that people watch TV in order to examine its effects on behavior. What is positive correlation? Relationship with, in which one factor increases as another does, or decreases as another one does. Both do the same thing. Like I told you, usually you're not going to see decreases as one does, because usually you would only look at that like in a different science class, like chemistry or something. But as far as psychology or like statistics, you usually just think of as the X increases. But anyways, why is random assignment important? Because it ensures that an unforeseen factor doesn't change due to a potential sampling bias, and therefore jeopardize the validity, whatever, validity, that's not a word, of the experiment by adding another factor. Create an example of a moderate negative correlation. As height increases, reckless behavior decreases, but not in all cases. So that's, but not in all cases. That's key. That shows that it's moderate. What type of graphic display is used to represent the values of variables in a correlation study? That happens to be the Scatterplot. Create a correlational coefficient to demonstrate strong relationship. Well, kind of already did that. I don't know why there's repeats. -0.92, negative or positive 0.94. Basically anything that's close to -1 or 1. If you chose something close to 0, that would be incorrect. What's the purpose of using random assignment? I think we already said that. I don't know why so many repeats. Oh, fancy there. Random assignment is used to prevent compounding variables. And that's it. What do you know? That's it for Module 6. So there you go. Thanks for watching.